Hello again, this is Module 5 Video 11. In this video we're going to write our wait action. Right, so first of all let me just create the classes we need. Righto, so wait action is the action that, to be honest, an exercise program would probably spend most of its time doing. It's just waiting around for the user to perform their exercises. So it will see a lot of use, probably implicitly through other actions, through higher level actions. But the idea is we would give this thing our wait service, as well as a time span telling it how long to wait, and it would just wait for that amount of time, but it would have to report progress as it's doing so, because you imagine if we've got a 5-second wait action, we don't want the user interface to be without any updates for 5 seconds. We want it to kind of be able to give feedback to the user as the wait action is progressing through its 5-second wait. So with that said, let's delve into some tests for this. Okay, so the first couple of tests are simple tests around construction. Make sure that we'll take a delay service and the time span as discussed, and we make sure that the delay service is not null and the time span is greater than 0. So we need to fix up this constructor. So I'm going to call that delay, not duration. I think that makes more sense. So if the delay is less than 0, so let's make sure our tests fail. Yep, failing, all good. So implementation here should be very simple. Actually, let me just add one more test here, another simple test. Okay, so need some private fields here for our delay service and our delay. Right, that should do it for those tests. Cool. So let's write the test for the more complicated aspect of this action, which isn't particularly complicated, but execute async is where it's at. Okay, so here are the tests I've added. I actually remembered this time to do the obvious check of the context when we pass it into the wait action execute async. It should not be null. I've got this test to make sure that we actually break for the delay that we specified. Now, the way I've done this is I've mocked out this delay service that whenever we call, or whenever something calls delay async on it, it adds on the delay amount onto this total delay here. So basically the wait action will be calling into the delay service to do the delaying, and we'll keep a running total of how long we've delayed for. And it will be doing it in chunks as we discussed. It won't just do the one delay because that would tie up that would prevent the user interface from showing any progress information throughout. And then we create the wait service and we tell it to delay for 850 milliseconds, and we expect a total delay consequently of 850 milliseconds. We've got skip ahead checks to make sure that if we pass in a skip ahead amount, the wait action automatically just kind of subtracts that off, if you will, of the total delay. So instead of delaying for 850 milliseconds, we're delaying for only 50 milliseconds. And we do the same thing even if the context is paused, per this assignment here. Then we've got a test to make sure that the execute async method updates the progress information in the context. So we are ensuring that it's 0 when we start, and then we await the action, and then we ensure that it's progressed 50 milliseconds afterwards because it's a 50 millisecond delay. And then we've got a couple more complicated tests to make sure that, for starters, that the logic bails out if the context is cancelled. Now this is a little bit unhappy with this, but let me explain how this works and why it works this way. So I've got my delay service mock. I've got a delay call count, which basically counts how many times delay async is called against our delay service. So once we get to the third call, we actually cancel the context. And the reason I've done it this way is, well, as discussed, it's going to delay in chunks. I didn't really want it to cancel straight away because that, that might be a different path through the code. I wanted to make sure that the wait action is actually kind of looping over and has made a couple of calls already to the delay service before we cancel. So then I create a wait action with a significant delay, because we need to make sure, when we get to the implementation of wait action, we're going to have to choose a chunk size. How long do we actually wait before we update progress? So let's say we choose 1 second. That means that a delay of 50 seconds would actually result in 50 calls to the delay service, each of 1 second. So if we were to change the wait action so that it was actually sleeping for, I don't know, 30 seconds before it updated progress, that would actually break this test because we would never get 3 calls to delay async. But I mean, that's just not going to happen because going 30 seconds without updating the user interface would be horrendous. So it's not such a bad thing. But I'm a little bit unhappy, that this test has kind of got a dependency on implementation details, even though we haven't even implemented it yet. We need to know that this delay async method is called multiple times. Anyways, having said all that, then I just await the execution and I expect the cancellation exception, and then just for good measure I assert that the context is cancelled after that. And then finally we've got this execute async pauses if context is paused, which is a similar thing except when the delay call count, when the third call is made, we pause the context. Now that implies that awaiting the wait action would actually just hang forever because something's pausing it, but nothing's unpausing it. The interesting thing is we can't really test that because the wait action will need to use, if you recall, our execution context has a wait while paused async. So the wait action will need to use this probably in the loop, so that if a pause occurs any time throughout the wait action, then the wait action will kind of stop where it's at and then continue once it's unpaused. But because our execution context is not something we can mock out, any calls against this method will actually block. So we instead, what I've got here is, I grab the task from the execute async, and then I assert that waiting for it for 50 milliseconds will not, or does not, succeed. In other words, that task is still running after this assertion. Now I could put in 3 seconds, but that means our test will run for a minimum of 3 seconds, which is just awful. So it's kind of a trade-off here between the time the test takes to run versus how sure we want to be that the task is actually paused. But in addition to that, after that, I've got this await here that checks the context is pause value, make sure that it's true, gets the first value in that instance, because remember this is an observable here. So basically what we're doing here is waiting for the context is paused property to change to true. We wait for up to 3 seconds. Obviously we wouldn't expect it to take that long, but if it does take that long, we want the test to fail, so that's why I've got the timeout there. And at that point we also do an assertion, which is probably completely pointless. Maybe I'll remove that because we know it's true at this point, because otherwise this would not have succeeded. So they are the tests. Let's make sure they build and fail. Yep, so got all the failures. That we expect. So let's look at the implementation. Start with the obvious thing here. So what we need is to try and figure out how long we actually have to delay, because remember we could have some skip ahead in the context here. So let's call this actual duration equals this dot duration. Or actual delay equals this dot delay. And then check the context for any skip ahead. No clue why Xamarin Studio is telling me this assignment is redundant. If the actual delay is less than 0, then make it 0. And it's telling me that's redundant. No clue what it's on about there. So now, actually I think I'm going to rename this to remaining delay, because after we subtract off the skip ahead, there may be some remaining delay, and that's what we care about when we do the actual logic here of waiting, which should look something like this. Okay, so what I've got here is a loop until our remaining delay is 0, then we keep looping over this logic here. And importantly, we have this check of the cancellation token and an await on the pause status inside the loop, so that even if we pause, throughout the process of delaying, then that pause will get picked up and this wait action will get paused. Okay, and then I've got this line. We need to figure out how long we actually want to delay for, and I'm checking this remaining delay against some constant that I haven't defined yet, which is the maximum delay time. So if we need to delay longer than the maximum delay time, then we just use the maximum delay time. Otherwise we use the remaining delay, and then we pass that delay into our delay service. And importantly, we can also pass our cancellation token through. And then we subtract off whatever we actually delayed for. We subtract it off the remaining delay and add it onto the context. And we continue. So let's define this guy. And I think I will set it just to 1 second. So this is basically another trade-off here between power usage on the device and how frequently we update the UI. I think having the progress on the UI update every second is absolutely sufficient. But yeah, I'm just going to use this as a starting point. If it turns out not to pan out very well, then we can change it at that point. So that is our wait action. Let's see if we pass our tests. Okay, perhaps unsurprisingly, it's stopped on something here. Execute async skips ahead if the context says skip ahead, even if the context is paused. Oh, we shouldn't expect that, should we? Because we are... should we expect that? Execute async skips ahead if the context says skip ahead, even if the context is paused. We are checking... Right, because we're awaiting it, it's going to be paused, and therefore this will block indefinitely, because nothing is unpausing it. So that's actually a faulty test. So instead, what I think we need to do is a similar thing to what we did before. Like that. So, I mean, this isn't strictly necessary, this line. We could just fire and forget this, but then we'll get a compiler warning, so I'd rather just do this assertion. And then we wait until the context says it's paused. And at that point we can do our final assertion here to make sure that the total delay is 50 milliseconds and not 850 milliseconds. So let's try that. One failure. Okay, we're still failing on that same test, but this time we're getting 0 instead of the 0.05 that we're expecting, or the 50 milliseconds that we're expecting. Might need to debug this one. Okay, yeah, so I was right the first time. This test is invalid because we are pausing before we even call execute async, which means this await here won't continue, so we'll never actually call delay in that instance. I guess what we need to do here is look at the progress instead of is paused here, and we don't really care that it is paused. What we care about is that this logic is running and is adding on to the progress of the action. So what we can do is just change this to progress, where x equals time span from milliseconds 800, because we want it to skip ahead 800. And then that's all we should really need to assert. Okay, so that's succeeding now. Right, so that's about it. There is one aspect I'm not happy with here, which is this logic here could still go wrong if the skip ahead in the context is greater than the duration of the task, of the action, sorry. And this was the same case in the previous video with the parallel action. You remember I had a debugger session, but I actually went back after that video and fixed everything up, so it's much nicer, and added another test as well. So I will do the same thing here, so that this is more robust. Even when it's past values that just don't really make sense, it will still work as we expect. But that's it for this video. Thanks again. See you later.